So it says find the dy dx. So go across the board. What's the derivative of y squared? 2y dy dx. Derivative of x squared? Derivative of sine xy. Cosine xy times, what's the derivative of xy? It's a product, so we gotta use a product rule. X, y. The derivative of x is, the derivative of y is dy dx. So we gotta do the plus sign since it's a product. So it's 2x plus cosine xy times y times 1 is y plus x times dy dx. Now we have to get dy dx by itself. How do we do that? Well, since this dy dx is over here, it's okay. This one's inside the parentheses, so I have to multiply. We have 2x y cosine xy plus x dy dx cosine xy. We have to get the dy dx's on one side. So this one has got to come over here to the other side. So 2y dy dx minus x dy dx cosine xy equals 2x plus y cosine xy. Okay, we have all the dy dx's on one side. How do we isolate it? On the left-hand side, we have dy dx in both of those. So we can factor out the dy dx. Gives us 2y minus x times cosine xy equals 2x plus y cosine xy. To get dy dx by itself, what do I have to do? Divide both sides by 2y minus x cosine xy. So that's my derivative. 2x plus y cosine xy 2y minus x cosine xy. That's my answer. It's just a lot of writing. You have to remember how to move things around, how to solve variables. Again, it's the algebra that's going to kill you. All depends on how much time you spent memorizing and learning algebra. What's that?
How do you find what did you find?
For xy, the derivative of that. This is x, that's y. The derivative of x is 1. The derivative of y is dy dx. So y times 1 is y plus x times dy dx. Okay, so that's just finding the first derivative. We can go higher. Higher order derivatives. Using implicit differentiation. Example 4. It says, find the second derivative if 2x cubed minus 3y squared equals 8. So whenever we find higher derivatives, we have to plug in some stuff that we've already done. So let's begin. So the derivative of 2x cubed is 6x squared. The derivative of 3y squared you have to put dy dx. If not, you'll get it wrong. You always forget the dy dx. The derivative of 8 is 0. Solve for dy dx. So subtract 6x squared from both sides. Negative 6y dy dx equals negative 6x squared. Change the signs. They both become positive. Divide by 6y. So the 6 again. So I have x squared over y. We have to remember this. That's the first derivative. Now we got to take the derivative of this equation. So the derivative of the derivative is d squared y over dx squared. Now we got to take the derivative of this side. We have a quotient. F is x squared. G is y. The derivative of x squared is 2x. the derivative of y is dy dx. So it's 2xy minus x squared dy dx over y squared. But we're not done. We're not done with this equation because what is dy dx? I can't make it any easier. If you just look 1 inch above there, you'll see what dy dx is. Two xy minus x squared times x squared over y squared. So we have 2xy minus, this is over 1, so it's x squared, it's x to the 4th over y. You have to get a common denominator. So we have to multiply y over y. Two x y squared minus x to the 4th over y squared. Is that a common denominator? It's fraction over a fraction. Two x y squared minus x to the 4th over y times 1 over y squared. Two x y squared minus x to the 4th over y cubed. And there's your answer. I said, is whenever you do higher order derivatives, you have to always replace the previous derivatives. If we did a third derivative, we will have a dy dx as well as a squared term. Then we would take this entire equation, plug it in that new one. But when we do applications, we'll have numbers we plug in there. So instead of x squared over y, we'd put a number in there. It makes it much easier. Oh, example 5. Let's look at that one. Show that the point show that 2, 4 lies on the curve x cubed plus y cubed minus 9xy equals 0. Then find the tangent and normal to the curve there. So first off, how do we show that that point is on that line? This is part A, this is part B, and this is part C. How do we do part A? Nope. Plug them in there. If it's on that line, then it'll equal 0. Is it x cubed? Y cubed. It's 2, 4. So 2 cubed plus 4 cubed minus 9, 2 times 4. Two cubed is 8. 4 cubed is 64. 2 times 4 is 8. 8 times 9 is 72. 8 plus 64 is 72. Yes, it's on that line. It's on that curve. So now we have to find the equation of the line tangent and the normal. I'll talk about what normal means in a second. So at 2, 4. To find the equation of a line, we need two things. We need a point and a slope. We have a point. Do we have a slope? No. How do we find the slope? Derivative. So take the derivative of this function. The derivative of x cubed, 3x squared. Derivative of y cubed, and minus 9. Now we have to do the product rule. Derivative of x is 1, derivative of y is dy dx. So it's going to be y plus x dy dx equals 0. Get rid of the parentheses. Actually, to be honest with you, we just plug in 2 and 4 inside there and solve for dy dx. But that's another story. Negative 9 times y is negative 9 times x is negative 9x. Put all the dy dx's on one side, non-dy dx's on the other side. So we have all the dy dx's here. So move this guy and that guy to the other side. Minus 9x dy dx. So that's going to be negative 3x squared plus 9y. How do we get dy dx by itself? Yep, factor it out. So we get 3y squared minus 9x. So we got dy dx. Three y squared minus 9x equals negative 3x squared plus 9y. Divide both sides by that. We can factor out a 3 out of both of them. Three's cancel, so we have negative x squared plus 3y, y squared minus 3x. So what's our slope? Nope. That doesn't tell me a slope. It tells me an equation of a slope. Plug in the 0.24 in there. So our slope of our line is negative 2 squared plus 3 times 4. 4 squared, 3 times 2. Negative 4 plus 12. 16 minus 6. 8 over 10. That's our slope. So we have a slope and we have a point. We're looking for the equation of a line tangent to it. So plug everything in there. Y is 4. The slope is 4/5. X is 2. We just don't know the y-intercept. 8 over 5 plus b. Multiply everybody by 5. We get 20 equals 8 plus 5b minus 8. 12 equals 5b. Divided by 5. B is equal to 12 over 5. So the equation of the line tangent is y equals 4 over 5x plus 12 over 5. So that's the tangent one. Any questions so far? What was the hardest part so far? Besides staying awake? Now we have to find the normal. Whenever we talk about something normal in mathematics, normal or orthogonal, we mean perpendicular. So whenever we want the equation of the line normal to that curve, we want it to be perpendicular at that point. So we know the slope originally was 4/5, right? Yeah. So what's the perpendicular slope to that line? If the slope is 4/5, what's the slope perpendicular to it? Wake me up when you tell me. That's part of it. It's the inverse of it. It's the opposite of it. You flip it and you change the sign. So that's the slope of the line normal to it. Going through the same point. So if this was our curve and this is our point at 2, 4, tangent would be that way. Normal would be like this. Normal would be perpendicular to it. We use the same formula. We have to solve for b. So we have 4 for the y, -5/4 times 2. We have to solve for b. The 2 and the 4 cancel. Multiply by the LCD. We get 8 equals -5 plus 2b. (13 equals 2b). So our y-intercept is at 13/2. Remember, our slope was -5/4. Plug it back in there. -5/4x plus 13/2. Slope of the line normal to our curve. I mean, equation of the line. Equation of line normal to our curve. At 2, 4. All right, that's it. So what do y'all think about implicit differentiation? We're gonna need this when we start doing related rates or how things move in 3-dimensional space. Okay, sorry I kept you all so long. Trust me, it'll be worth it because if we could finish up chapter 3 this week, then I'll give you all next week to catch up. Which we will. We'll finish, we only have 2 more sections left. And we're gonna meet Thursday and Friday. So I want to start chapter 4 as well. So when we come back after the 4th of July weekend, a week, then we'll only need couple more days left to finish everything. Unless you guys want to finish early. You guys want to finish early next week? It's up to y'all because we have 2 more sections in chapter 3. We have 6 sections in chapter 4. This is all we have left. We just did chain rule and implicit differentiations. Now we have inverse functions. We'll do those tomorrow. And then we have these 13 sections, chapter 4 and chapter 5. So what I'm looking at is we'll finish chapter 3, we'll finish those tomorrow. On Friday, we'll start these. Chapter 4 is pretty short and sweet. It's pretty quick and easy, actually. Until we get to this part down here. It's just a lengthy process. So we could do this on Friday. Yeah, we'll finish up tomorrow and then we'll start chapter 4 after 4th of July then. If you're all okay with that. Unless you guys want to meet next week or Monday. Is everybody okay with it? I mean, yeah, I gotta be here anyway, so if you guys want to come here or not. How many of y'all have finished chapter 2 and chapter 3 stuff already? Okay, so, I mean, I can always look online and see what y'all doing. Because when we get back, chapter 4, we'll finish up using derivatives, learning how to graph with them. Those are pretty short and sweet. But chapter 5, we do integrals, antiderivatives. To find areas under curves. All right, think about it. We'll talk about it tomorrow. Hot tie, everyone. I gotta go through and redo everything up to the beginning of this section. Yeah, I didn't start recording till example 3. Which sucks because I did the same thing in my algebra class. I forgot the whole section. Oh, you know.
It's like, it's how much stuff you would do in 16.
Pretty much, yeah, on the easier stuff, was, well, we just did the 2 sections we did, the composite, I mean, the chain rule and the implicit. Those have to go together and they flow much easier because we had a couple times we had to use the composite functions. And yeah, it's pretty much the same. Yeah, it's pretty same pace because typically we finish the calculus course with about 3 weeks to spare. 3 or 4 weeks to spare.
It's not gonna allow the pace of this.
I do too. As to be honest, I like it 4 days a week. So that way you don't forget
Yeah, I
everything.
can say it's consistency, right? You're doing it every day.
Exactly. And it's the consistency that's gonna help you all. Okay, get out of here. I mean, have a great day.
Have a good one.
You too, thanks. Yes, sir.
When is this class end?
August 8th. But actually, we're gonna finish probably in about 2, maybe 3 weeks.
Oh,
Why is that?
I don't know, because I'm confused. This one, it says my class is done by the 20th.
That's the drop date.
Yeah,
It begins September 3rd or June 3rd, and it goes for 10 weeks. This is a drop date. It goes on to August 8th.
oh, okay.
This is just a drop day. This is the last day you can drop with a W.
Oh, okay. And the next class I have this,
What time's that one? Yeah, that one's the morning time, so we're still good.
oh, okay.
But yeah, we're gonna finish chapter 3 this week. And chapter 4 will take us a week, and chapter 5 will take us a week. So we'll finish the first 2 weeks of the next 5 weeks. So you'll have 3 weeks to do the other class.
Oh, okay,
So plenty of time.
okay. I was confused, I was worried.
Yeah, oh, no, it's what did you eat back there? You looked good. Oh,
You want some?
no, thanks, no. Actually, I'm gonna go meet my wife for lunch.
Oh.